Hello, everybody. So I'm posting this video to clarify the problems that came up today with Google Colab. I think it's a good software to use, and I think it's not a bad idea to actually use Google Colab. I'm actually, given all the problems everybody has with R and the installation of R, I'm actually leaning towards really using Colab more often. So, but anyways, so some of you use Google Colab, and Google Colab is basically a Python programming platform. Therefore, you will need some codes that basically using Google Colab for R. So this is the link that I shared with some of you that approached me how to use R in Google Colab. So essentially, Google Colab is a Python programming platform provided for by Google. You can use R in there. It's basically it's kind of included in it in some shape and form. You just need to access the actual so basically you can start it by using the so-called R magic. And this is the code how you can actually do that. So everything is a little slow. That's what the main problem is. So this is Google Colab. So you get to this essentially by a Google account. You can go on File, go on New Notebook. Basically, you get a new notebook opened up. Then you just need to copy this line. You go on this new notebook. And you essentially type, you copy paste this code, and you run this. Once you've ran that, you essentially are connecting to an R application within your Google Colab. So essentially, then you just need to start, just like this post here suggests, with %% you indicate that what you're writing is not in Python code, but you're indicating it's an R code. And then you can use these blocks, and you can create several of these blocks, right? You can do many blocks that you add. And if you want to have an R code, it's a little bit more R-like, so it's not like as easy to use as RStudio. But if you go, for example, now into our code from today and we did in class, and you go to practice labs, you take the completed code. You can basically run the very same analyses that we ran today in RStudio without a problem in your Google Colab environment. So essentially what you do, you open just the code, again with the text editor. And you copy paste these fractions that you want to work on. So I would probably recommend to always start with clear environment. That's always a good one, as indicated before, although that is a superfluous command essentially in Google Colab when you open a new network. In any ways, you need every of these blocks need to start with %R. By that, you indicate that you are starting an R command. So now you're building the data frame. You go through the struct data. And now when you are running this code, it will basically create like this. Oh, I didn't copy that. Of course, you need to be careful to copy the whole thing. Okay, we didn't do. Okay. Okay. So if you run this now, you're basically creating your Stroop data. This is the very same Stroop data that we worked with today in class. Just make a couple of enters to see a little bit more of that. So now we are going on DFM2. So now we can actually look again with Control Enter. You can see the data frame here, addressing it in the same way and function. So it's just graphically, it's a little bit harder to work with. It's not as easy as, for example, we did it in class. So, but again, you can do the same things. You can do DFM2. You can see here the congruence. Then you can, again, here also show the incongruence. Okay. You just go one by one. You go through the same code. You're doing essentially the same thing as we did in class. So here we're doing the counting. So here we're counting DFM2 congruent and incongruent. Gives you the same results. Obviously, for obvious reason, it will be the same result. Then we count by criteria. We can use here only the depiction of those that are essentially greater than 15. So here we see a subset of those that are greater than 15. Now we can also count those that are greater than 15. Now we can, in the next step, we can individualize the threshold. And we're using as the distinguishing criterion, not the 15 hard-coded anymore, but we're defining the threshold manually. And we're using now, moving forward, we're using the threshold rather than the actual so if we're assigning threshold to here, I need to build smaller blocks. Myself not that familiar with. Okay, so we can manipulate things here and these. That's %% R basically. Here we have DFM2. If we start now here writing threshold, the threshold is 15. If we are now putting all these commands in, we will essentially no, it doesn't like that particular aspect of it. That's interesting. So you will basically need to build different blocks that allow you. Okay, I did a little snooping and finding. So I found now a way how to actually do that. So yes, it's definitely one way to do this with R magic. It's a little laborious because then every cell has to start with %%R. A better way to do that is essentially when you use the direct kernel. And this essentially can be used either with this link. So this is Stack Overflow. This is one of the best resources. So you basically go on Google colab.to/R, and you're entering this here. Make sure to not only take colab.to/R, and that will basically get you to a new workbook. And this workbook essentially is an R and Python workbook at the same time. So from here, basically you can literally copy paste that code, and it will basically allow for you to run all the commands we did today. So you see how it's loading it. So basically you are at this point running the congruent and the incongruent. You get this subset. You get the subset of incongruent, you get here the count, you get the count, and you get the dimensions. If you open a new code, you can one by one count as per criterion. So you can run this portion where we're only counting those with a reaction grade greater than 15. I'll put the hashtag here. Always make sure that you're very diligently looking at what you want to do. So here we get, so this always corresponds. The first line corresponds with this line. The second line corresponds with this line. Third one with this, and this is only the ones that are greater than 15. And then we have incongruent greater than 15. This is all 24 or longer than 15. So if we individualize the criterion as per threshold, we're basically seeing the same dynamics. For all these snippets, I would not use more than 3 to 4 lines in this code. I would probably keep it very short. So these are now, threshold is not defined. You can show the threshold after you assigned it. So here, for example, you see 15 is the threshold. You see here congruent and incongruent. You see here lengths and the length of incongruent. You can do the same thing now here with code. You just create a new snippet. You basically go on the mean. This is the mean. This is the mean as per this threshold. This is the mean for all the incongruents, and this is the difference between the mean incongruent and mean congruent. So this is the difference. If we're going now for the volcano example, you're seeing also here that we can build up our volcano example fairly swiftly. We're basically building here the volcano examples. This is the frequency table comes in the next snippet. This is the volcano. And now we have our volcanoes. That was left over from the first one. Okay, deleting that. Just the volcanoes we want. Running this, here we're assigning the volcanoes. Now we're taking the frequency table, we're taking this portion of our code. We're putting this in a new code block. We're running this here. Now we have here the frequency table, right? So we have this empty shell of frequency table, and here we have the finalized shell. And this is basically this iterative loop that counts through each of these entries and assigns this criterion, counts this criterion based on this criterion block. So now this is now our plot, athletic performance. We can also do this in our deleting the frequency table that's kind of left over. And running this, and we see our plot nicely presented. So now again, we go on the next one. This is the charity navigator. Here we see our calculations. This is basically the next example. Here you see the histogram and these respective calculations. This is the quantile of 25, 75. This is the third quantile, this is the difference. This is the actual IQR. And so now you want to print this. You basically can print this now in Google easily. In Google Chrome, for example, you can do this easily in save as PDF. Take a while to load. Here you see all these outputs basically shown. Not really nicely shown, I have to say that. Cut them. It's not really nice. Okay. Yeah, but if you show me that you have ran this in Google, that would be sufficient for a submission. So here you can basically now you save it in your actual folder. You go in your folder, you save it as your practice lab. This is stat 1021 name and practice lab. Okay. So this is basically what I did. Need to show you to that. You can also export it as a PY code. So this is actually this now the code that we have built. You can download this code then once it's finalized and look at it and save it for later challenges you may have with analyses. But yeah, so this is how you use Google Colab. And this is the code that you want to use. This is your actually link that will allow you to start Google Colab in an R environment. Okay, I hope this helps and solves some of the problems. All right. I see you on Sunday at 3 p.m.